frying chicken.
Hello everyone. Welcome back to Agriculture Insight. Have you ever wondered how KFC manages to produce billions of perfectly golden, crispy, and irresistibly delicious fried chicken pieces that the whole world is obsessed with? From the legendary original recipe, the fiery hot and spicy that sets your taste buds ablaze, to the bite-sized, tender, juicy nuggets packed with flavor. Let's be honest, how many times have you unconsciously licked your fingers after taking a crunchy bite? KFC's success isn't just about its iconic flavors. It's also built on a tightly controlled supply chain and state-of-the-art production process, ensuring that every single piece of chicken meets the highest standards before reaching customers. From carefully managed farms to cutting-edge frying technology, every step is meticulously monitored to deliver an unbeatable dining experience. Today, Agriculture Insight is taking you inside the massive fried chicken production facilities, the ultimate secret weapon that has made KFC the Elon Musk of the fried chicken universe. Let's get started. What's the dream of millions of baby chicks? To become a crispy, golden fried chicken piece sitting proudly on a plate, and when someone takes a bite, sheesh, that's bussin'. But those millions of crispy dreams became reality thanks to one man's dream. Back in the 1930s, Colonel Harlan Sanders created his legendary recipe using 11 secret herbs and spices. At the time, no one could have predicted that these crispy fried chicken pieces would go on to change the global fast food industry forever.
Never even touch it, huh? Wow, that's pretty cool.
And then you're going to put it right up here with the dry rub.
Okay, so can I give it to these guys here? Take it. Happy birthday, Kamala. Happy birthday. See you later.
From a small roadside diner to a fast food empire with over 27,000 locations worldwide, KFC has even surpassed McDonald's in the fried chicken game to become the undisputed king of crispy goodness. Every year, over 1 billion chickens end up in KFC meals. If they knew this staggering number, they'd probably be planning their great escape to Mars. An incredible journey, an unstoppable fried chicken empire. It all started with a secret recipe in the kitchen of a man who simply loved to cook. Every crispy, golden bite of fried chicken you enjoy starts at modern poultry farms, where advanced technology works hand in hand with skilled farmers to ensure the highest quality ingredients. Gone are the days of chaotic chicken chasing on farms, thanks to automated poultry catching systems, which can process 8,000 to 10,000 chickens per hour, optimizing efficiency without relying on manual labor. When the time is right, specialized machines gently enter the barns, using flexible arms and rotating brushes to guide the chickens onto a dedicated conveyor belt. This ensures a quick and stress-free process. Each chicken is carefully placed into transport crates designed to protect their health and well-being. The automated conveyor system adjusts in real time, providing enough space to minimize stress before the chickens are transported to the processing plant. Pretty impressive, right? As the fully loaded trucks roll into the processing plant, the doors to a highly controlled and efficient production system open. To reduce stress and enhance meat quality, chickens are given a resting period of 1 to 2 hours before further processing begins. After resting, chickens are placed onto an automated rail system that securely holds them in place. Here, they undergo a controlled stunning process using either low-voltage electrical currents or gas anesthesia. This ensures a calm and humane transition to the next step. Next, chickens move through an automated processing area, completing the step in just a few seconds to maintain meat quality. They are then immersed in a hot water bath at 50 to 60 degrees Celsius for 45 to 60 seconds, which loosens the feathers for easy removal. Immediately after scalding, chickens pass through an automated feather removal system, equipped with rotating rubber fingers, which pluck the feathers evenly and efficiently without damaging the skin. Once feather-free, the chickens move along the automated processing line to the leg cutting section. Here, precision cutting blades can process 10,000 chicken legs per hour, ensuring uniform sizing. The removed legs are transported via conveyor belts to a separate processing area. Next, chickens enter the evisceration stage, where a vacuum-powered system removes internal organs swiftly and hygienically. This method maintains food safety while preserving the integrity of the chicken carcass. The extracted organs are then transferred to a specialized processing system for further handling. After the chickens have been eviscerated, they are passed through an optical scanner to detect any defects or abnormalities on the carcass. Any chickens that don't meet the quality standards are automatically removed from the production line to ensure the final product meets high-quality standards. Next, the uropygial gland, tail gland, is precisely removed using an automated cutting system. Chickens then pass through a quality inspection chamber, where advanced sensors and trained inspectors verify that each bird meets strict food safety standards. Next, chickens enter the wing cutting section, where an automated blade system processes up to 20,000 chicken wings per hour with perfect precision. The wings are then sorted by size and purpose. Some are sold whole, while others are sent for further processing into ready-to-eat products. Once the wings are removed, the chicken body moves forward on the specialized cutting system, where each part is separated with extreme precision. First, the chickens pass through a high-speed stainless steel blade system, capable of processing 12,000 chickens per hour. This evenly splits each chicken in half without compromising meat texture. The breast meat is carefully separated using an automated filleting system, ensuring that each piece remains intact, tender and juicy, ready for cooking or packaging. Meanwhile, chicken thighs are sent to a separate section, where automated cutting blades process up to 15,000 thighs per hour, ensuring consistent sizing and clean cuts. Moving forward, the chicken pieces enter the processing line, getting ready to become the world-famous crispy, flavorful KFC fried chicken. On an automated conveyor belt, each piece moves through the first dry battering station. Precision-engineered robotic arms evenly sprinkle a fine layer of dry flour over the chicken, ensuring it adheres firmly to the surface. The system is programmed to achieve uniform coverage, creating the perfect crispy coating that fans love. Next, the chicken pieces proceed to an automatic wet battering station, where they are evenly coated in a liquid batter. This step enhances moisture retention and helps the next layer of dry coating stick more effectively. Finally, the chicken receives a second and final layer of dry flour. Thanks to the previous wet batter, this last coating adheres perfectly, setting the stage for that signature golden, crispy texture after frying. Once fully coated, the chicken pieces are placed into an industrial fryer, cooking at 177 degrees Celsius for 12 to 15 minutes. This ensures a crispy, golden brown exterior while keeping the inside tender and juicy. KFC takes it a step further with another irresistible option: chicken nuggets. These delicious bites are made from finely ground chicken, blended with KFC's signature seasonings to create a rich, flavorful taste. Next, the nuggets move through an automated dry battering station. Then, they pass through the wet battering system, where a special coating is applied to enhance adhesion and maintain their shape during frying, resulting in a perfectly crispy, golden crust. Depending on the product type, some nuggets are further coated in panko breadcrumbs, adding extra crispiness and a satisfying crunch. After that, they are fried at approximately 170 to 180 degrees Celsius for 2 to 3 minutes, ensuring a crispy outer layer while keeping the inside juicy and flavorful. Finally, the freshly fried nuggets are sealed in protective packaging, then neatly packed into specialized cartons, ready to be shipped to KFC locations around the world. Let's go back to the happy farms where baby chicks are brought into the world and raised with expert care and cutting-edge technology. In large-scale farms supplying the food industry, artificial insemination is the preferred method for ensuring breed quality, improving fertilization rates, and minimizing the risks of natural mating. The process begins with collecting semen from roosters. Farmers use specialized tools to gently stimulate the reproductive glands and extract semen into a small funnel. The semen is then tested for quality before being carefully injected into hens using a special syringe, ensuring the highest fertilization success rate. Around 10 days after fertilization, the hens begin laying smooth, round eggs. In modern poultry farms, automated egg collection systems optimize production, reduce labor costs, and maintain egg quality. As soon as a hen lays an egg, It gently rolls onto a specialized conveyor belt, which transports it to the sorting and inspection system. Thanks to advanced technology, a single farm can collect up to 300,000 eggs per day, minimizing waste and upholding the highest sanitation standards. But the journey of these eggs doesn't stop here. Each egg is placed in a high-tech incubator designed to create the perfect conditions for strong, healthy chicks to hatch. Inside these incubators, the eggs are kept at an optimal temperature of 37.5 to 38 degrees Celsius, with humidity levels between 50 to 60%. The system automatically rotates the eggs every 2 to 4 hours to ensure even development of the embryos. After 21 days, tiny baby chicks break free from their shells, unknowingly carrying the same dream as the legendary Colonel Sanders, to one day become delicious, golden brown fried chicken, beloved by KFC fans worldwide. Without making you wait, let's dive into the magical process that transforms wheat from sunlit fields into top-quality spaghetti and delicious pizza. First, as soon as the wheat leaves the field, it's transported by specialized trucks to large storage centers, where it's unloaded into silo towers that rise dozens of feet high, with a capacity of up to 60 million pounds. These silo towers not only protect the wheat from mold and insects, but are also equipped with automated temperature and humidity control systems, ensuring the wheat maintains its optimal quality, ready for the next stage. In pasta production factories, durum wheat is selected as the main ingredient to create the firm and delicious pasta strands we commonly see. First, when the wheat is fed into the roller mills, the milling process begins with the goal of removing the outer husk and extracting the endosperm to produce semolina. Initially, the large roller mills press and break the outer husk without damaging the inner core, preserving the integrity of the endosperm. Next, the wheat passes through a sifter, which completely removes the husk, leaving only the pure endosperm. The endosperm is then transferred to smaller roller mills for further grinding, breaking it down into coarse semolina granules, which are larger than regular flour particles. After grinding, the semolina is sieved through a vibrating sifter, plan sifter, to classify the granules by size, ensuring consistency in the final product. Next, the semolina flour is conveyed through pipes and directly poured into specialized mixing tanks, where it's combined with a small amount of water, around 30 to 35%. This process forms clumps of dough, and to ensure a smooth, uniform texture, kneading arms continuously knead, soften, and break apart these clumps. The dough is then transferred on a conveyor belt into centrifugal sifters, where a filtering mesh removes any remaining large clumps. The resulting flour has a golden hue and a coarser texture than regular wheat flour, but it's rich in protein and gluten. This is what gives pasta its ideal chewiness and perfect texture when cooked. To ensure the highest quality, the semolina flour is sifted multiple times to classify grains of uniform size, ready for the next stage of pasta production. Once the dough has been mixed, it is fed into an extruder, an essential piece of equipment in pasta production lines. And here is the result of the modern spaghetti shaping process, where over 3 million strands of pasta are produced every minute, perfectly uniform in size and glowing with a golden hue, flowing down the conveyor like silky ribbons. After shaping, the pasta undergoes a crucial stage, drying. The freshly extruded pasta, whether in strands or tubes, still contains a significant amount of moisture, and if not dried properly, it can spoil easily. Therefore, the pasta is placed on trays or conveyor belts and fed into a modern drying chamber, where warm air circulates evenly, reducing the moisture content to around 12 to 13%. This stage not only ensures the pasta can be stored for a long time, but also determines its chewiness, texture, and ability to retain flavor. Once dried, the pasta goes through another important step, cooling. The pasta still retains high heat after exiting the drying chamber, so the cooling process helps stabilize the temperature, stop the drying process, and reduce unwanted shrinkage, preserving the quality and shape of the pasta. The pasta is cooled in a spacious area with fans and air conditioning systems ensuring even cooling and preventing deformation of the product. Finally, when the pasta meets quality standards, it is transferred to a fully automated packaging system. Here, each pasta package is sealed into its packaging, and sharp blades efficiently cut the packs apart, ensuring they don't stick together. This entire process ensures that wheat is carefully transformed into high-quality pasta with precision and efficiency. From storage in massive silo towers to cleaning, grinding, mixing, shaping, drying, and cooling, every stage is meticulously controlled to maintain the perfect texture, color, and durability of the pasta. Thanks to advanced automation, billions of strands of spaghetti and countless other pasta shapes are produced daily, ensuring that every bite delivers the ideal chewiness and ability to absorb flavors. And there's one more process that I think will amaze and excite you: the production of macaroni. Let's dive into this fascinating world together. And now, the macaroni moves into the packaging process, operating at an impressive capacity of over 10,000 pounds per hour, ensuring it is sealed, packed, and ready to reach consumers. My friends, keep that excitement alive as we step into the next amazing process, the making of delicious pizza. The next stop for the wheat grains is the pizza production plant, where they are transformed into an essential part of delicious pizzas with a crispy crust and irresistible flavor. Flour, water, yeast, and olive oil are blended together in large mixing tanks to form a smooth dough. Robotic arms gently knead the dough to the ideal texture before moving it to the rolling system. The dough gradually spreads into evenly shaped sheets, which are then cut into perfect round pizza crusts, each with precise dimensions. Each crust continues its journey on the conveyor belt, ready for the next steps in the process. The conveyor belt gently carries each crust through the tomato sauce spraying system, where nozzles are precisely programmed to evenly spread the vibrant red sauce, bringing out its signature sweet and tangy flavor. Next, a cheese dispenser works delicately, covering each pizza with creamy cheese strands. In the blink of an eye, robotic arms continue their work, carefully placing slices of pepperoni, mushrooms, olives, or bell peppers on top, creating a balanced and visually appealing masterpiece. Once the toppings are complete, some factories immediately send the pizzas into a deep freezing system to lock in freshness and make storage easy before they reach consumers. These pizzas only need a few minutes in a home oven to be ready to enjoy, offering both convenience and the delicious taste of fresh-baked pizza. In some pre-baked pizza production facilities, the journey takes a different turn. After being topped, the pizzas are not frozen, but go directly into industrial ovens, heated between 570 degrees Fahrenheit and 850 degrees Fahrenheit. As the pizza slides through the conveyor belt in the oven, the crust slowly turns golden brown, and the cheese melts, blending with the delicious toppings. And now, get ready to be amazed as we explore another incredible factory that will leave you in awe. The story of almonds begins long before the bountiful harvest. In January or February, young almond trees are planted in California's Central Valley, often called the almond capital. They are arranged in evenly spaced rows and paired with drip or sprinkler irrigation systems, designed to deliver water and nutrients precisely and efficiently. Drip irrigation directs water straight to the roots, reducing evaporation and waste, while sprinkler irrigation evenly moistens the soil surface and delivers fertilizers through the water, providing timely nutrients throughout the tree's growth to maturity. During the first 1 or 2 years, American farmers focus on developing sturdy canopies and strong root systems, using modern machinery to prune dead or overlapping branches so every tree receives ample sunlight and grows into a healthy shape. By the 3rd or 4th year, the trees bloom in vibrant pink and white, signaling the start of pollination, a process supported by 2 million beehives in what is known as the largest pollination event in the world. This bustling scene showcases the unique collaboration between beekeepers and almond farmers, ensuring a successful harvest that allows the trees to reach their peak by the 7th year and continue bearing nuts for over 20 years. After months of nurturing under the summer sun, by late summer to early fall, the green outer hull of the almond nut cracks open like a smile from nature, signaling the perfect time for harvest. We cannot overlook the iconic sight in almond orchards, the tree shaker. These specialized machines are designed to clamp onto the trunks of almond trees and deliver powerful shakes, causing the almonds to fall to the ground, creating an amusing nut rain. The tree shaker is a marvel of agricultural engineering. It consists of a mechanical arm equipped with hydraulic actuators securely attached to the tree trunk. When activated, the shaker generates rapid and precise vibrations. These vibrations resemble dancing with the trees, causing the almonds to detach from the branches and fall to the orchard floor, ensuring an even and efficient harvest. The sweeper is another advanced piece of machinery equipped with rotating brushes that gently sweep the almonds into neat, elongated rows known as windrows. These windrows are strategically placed between the rows of trees, creating orderly lines of nuts ready for collection. The sweeper operates smoothly, ensuring that the almonds are gathered efficiently while minimizing disturbance to the remaining leaves and soil. By arranging the nuts into manageable rows, the sweeper facilitates quicker and more efficient collection by the pickup machines. This meticulous process not only speeds up harvesting, but also helps maintain the quality of the almonds by reducing the risk of damage during collection. After the almonds have been sun-dried for a few days, a machine called a pickup or almond pickup machine moves along the windrows, sucking up or gathering all the almonds and transferring them to a truck. The pickup machines are typically equipped with advanced filtration systems to ensure that only almonds are collected, while debris such as leaves, dry branches, and dust are completely removed. This is a smoothly coordinated operation aimed at cleaning up the nuts while minimizing dust. The seamless blend of traditional farming expertise and cutting-edge modern technology allows American farmers to harvest billions of pounds of almonds each year and leads the world in almond production, commanding 80% of the global market. From here, due to the massive harvest volume, the almonds are stored in large temporary storage areas, ready to move on to the next stage of their journey at the processing facility. When almonds are transported to processing facilities in the United States, they typically arrive with their green hulls and hard shells intact, along with various impurities such as dry leaves, twigs, and dirt. Before the hulling process begins, the almonds undergo a thorough pre-cleaning procedure. First, they pass through the de-sticker machine, which effectively removes large sticks without damaging the nuts. Next, they move to the de-stoner machine, where airflow blows away lighter debris and vibrations help separate soil clumps and dirt from the almond surface. Finally, the almonds go through the de-twigger machine, which completely eliminates any remaining small twigs and debris. After completing these 3 preliminary cleaning steps, the almonds are transferred via conveyor or line to the next processing stage. Next comes the hulling process. This process begins by loosening the green hulls using a rotating mechanism or gentle friction. Workers periodically inspect the almonds to ensure the hulls have been properly removed. The hull fragments are then removed using a vacuum or air suction system, ensuring no debris remains on the production line. After the outer hulls are removed, the almonds are transferred to a gravity table to further separate any remaining impurities. Almonds that still have their hard shells move along the mainstream, where they undergo quality inspection through a camera system. This step quickly removes defective almonds, preparing them for the shelling process. The almond shelling process begins by feeding the almonds, still encased in their hard shells, into specialized shelling machines. These machines use gentle mechanical force to crack and remove the hard outer shells while ensuring the almond kernels inside remain intact and undamaged. Once the shells are removed, the almonds are transferred onto vibrating conveyors equipped with filtering holes to sort them by size. Smaller almonds fall through the holes and are collected into separate bins, typically designated for products like almond butter or baking ingredients. Larger almonds continue along the conveyor, prepared to meet the demands of premium market segments. Cameras detect scratches, small cracks, and broken pieces, then send the coordinates to the robot for removal. Afterward, workers perform a final inspection, to eliminate any almonds that the robotic system may have missed. This combination of advanced machinery and meticulous human oversight ensures that every almond meets the highest quality standards, ready for the next stages of processing. Steam pasteurization is the most widely used method for almonds in the US, where hot steam is briefly applied to eliminate harmful bacteria like salmonella. This process is highly effective, preserving the almond's natural flavor and texture while meeting strict food safety standards. After being sterilized, the automated packaging machine seals raw almonds into 50-pound or 100-pound packages, ready for consumers. Additionally, larger boxes are transported to other facilities for further processing, such as crispy salted roasted almonds, nutrient-rich almond milk, or sweet toffee almonds. For salted roasted almonds, they are placed in an oven or automated roasting machine and roasted at a temperature of 150 to 180 degrees for approximately 10 to 15 minutes to ensure they are evenly cooked and crispy. While still hot, the almonds are sprayed with salt or coated in a saltwater solution to ensure even seasoning. Finally, the almonds are quickly cooled and packaged in airtight containers, ready to be delivered to consumers. The process of making almond toffee is a delightful journey of sweetness. Sugar, butter, and syrup are heated in a large pot at 120 to 150 degrees Celsius, with continuous stirring until the mixture achieves a golden brown color and the perfect consistency. Once the toffee is ready, almonds are evenly mixed into the blend and poured onto a non-stick mold, spreading out to showcase its rich golden hue. After cooling, the toffee is cut into bite-sized pieces and packaged in airtight containers, preserving its crunchiness and sweet, irresistible flavor. Bell peppers shine in a spectrum of colors, each with a unique taste. Green peppers are crisp and tangy, while yellow and orange bring a mild sweetness. Fully ripened red peppers are the softest and sweetest, packed with natural sugars. To thrive, bell peppers require warm temperatures, plenty of sunlight, and an ideal climate range of 65 to 85 degrees Fahrenheit. From flowering to full ripeness, the plants take about 60 to 90 days to complete their growth cycle. This process isn't just dictated by nature, it's also the result of continuous advancements in cultivation techniques. Once the peppers reach their peak ripeness, they enter the most crucial stage: harvest. Across vast bell pepper fields, a massive harvesting machine rolls forward, orchestrating a seamless dance of mechanics and precision. A single modern harvester can collect up to 20,000 pounds of bell peppers per hour. As the machine moves in, its front conveyor lowers gently, guiding entire rows of peppers into the system. Instantly, a series of vibrating mechanisms shake the peppers loose from their stems, while powerful air jets blow away leaves and small branches. The peppers then travel along the main conveyor toward the sorting area. Here, a team of workers lines both sides, carefully inspecting each passing pepper. With swift hands, they remove any damaged, misshapen, or leaf-covered peppers that don't meet quality standards. Only the best peppers continue down the conveyor, where a long mechanical arm extends from the harvester's body. In a steady stream, the peppers cascade into a moving trailer running alongside the machine. On board, workers quickly arrange them into large storage bins, ensuring they are ready for the next stage of their journey. Alongside machine harvesting, some farms still rely on manual labor to pick bell peppers. While this traditional method is more time-consuming and labor-intensive, it ensures that each pepper is picked at peak ripeness and remains free from bruising, making it especially suitable for delicate, thin-skinned varieties or organically grown crops. Across the sprawling rows of plants, farmers move swiftly, bending down and carefully reaching through the lush green foliage to find peppers that meet the right standards. Using sharp pruning shears, or sometimes just a quick, skillful twist, they detach the peppers cleanly from the stems. Each worker stays focused on their assigned row, moving efficiently as they drop the peppers into collection bins lined along the field. Once a bin is full, they lift it and carry it to waiting trailers at the edge of the field, where the freshly picked peppers are loaded up for the next stage of their journey. With advancements in agricultural technology, bell peppers are no longer grown solely in open fields. They also thrive in high-tech greenhouses. Inside these controlled environments, workers move carefully along the rows, meticulously inspecting each plant to harvest only the peppers that have reached peak ripeness. They gently twist the stems or use sharp pruning shears to detach the peppers, ensuring the plants remain undamaged. The freshly picked peppers are then placed into collection bins that glide along rail tracks or wheeled carts, automatically transporting them to central sorting areas for further inspection and quality control. Some of the most advanced farms take efficiency even further with automated harvesting robots. Equipped with optical sensors and precision robotic arms, these machines can accurately determine the ripeness of each pepper. Once a suitable pepper is detected, the robot delicately snips the stem and places the fruit onto a specialized conveyor belt, sending it directly to the packing area. This minimizes bruising, optimizes the harvesting process, and enhances product quality. As the harvest wraps up, crates filled with vibrant red, yellow, and green peppers stack up, ready to continue their incredible journey to processing facilities and beyond. At the factory, bell peppers undergo a rigorous process where modern technology meets human precision to ensure optimal quality. Here they are sorted, processed, and carefully packaged, whether as fresh produce or canned goods, before making their way to consumers. Vibrant crates of bell peppers arrive directly from farms and are unloaded at the receiving area. Automated mechanical arms lift each crate, gently emptying the peppers onto the main conveyor belt. At this stage, the quality control team conducts an initial screening, removing any bruised, damaged, or pest-affected peppers that fail to meet appearance standards. Only firm, high-quality peppers continue the cleaning process. The selected peppers are submerged in large water tanks, where clean water or a mild sanitizing solution helps remove dirt, chemical residues, and harmful microorganisms. High-pressure nozzles then spray water from multiple angles to ensure a thorough cleanse. Next, the peppers pass through a set of soft, rotating brushes, which gently scrub away any remaining debris while enhancing their natural shine. Finally, an air drying system removes excess soil moisture, preparing the peppers for sorting. Once cleaned, the bell peppers move onto an automated sorting conveyor where they are classified by size, color, and overall quality. First, a guiding system arranges the peppers in neat rows on rolling conveyors. High-resolution optical sensors scan each pepper, precisely identifying its size and color. Then, an automated weighing system determines the exact weight of each pepper before mechanical pushers or small trapdoors redirect them to their respective sorting lanes. Some factories even employ AI to analyze shapes and detect minor imperfections invisible to the human eye. As a final checkpoint, workers manually inspect the sorted peppers to ensure that only the highest quality ones move forward to packaging. After sorting, the bell peppers are packed into various formats depending on market demands. For wholesale or export, peppers are stacked in ventilated cardboard or plastic crates to maintain freshness during transport. For retail markets, they are often packaged in plastic trays or shrink-wrapped bags to prevent bruising and extend shelf life. Each package is then labeled with key information, including origin, packing date, and quality standards, before being transferred to cold storage. Finally, the packaged peppers are shipped to supermarkets, grocery stores, or exported worldwide, ensuring consumers receive only the freshest, top-quality produce. Alongside fresh bell peppers, a portion of the harvest is processed into canned bell peppers for long-term preservation. For canning, once the peppers are thoroughly washed, they are sent to the trimming and cutting system, where their stems, seeds, and white cores are removed. The razor-sharp blades spin rapidly, gliding through each bell pepper with absolute precision, removing the stem and seeds in an instant. Under the control of an automated system, the process runs seamlessly, ensuring that every piece is neatly and uniformly cut, ready for the next stage of production. In some factories, manual workers still perform this step, using specialized cutting tools to swiftly remove the stems and cores. After trimming, the peppers move along the conveyor belt to the blanching system. Here, they are briefly immersed in hot water for a few seconds. This step helps maintain their bright color while inactivating enzymes that could cause spoilage, ensuring they are ready for the next stage of canning. The prepped peppers are automatically transferred into sterilized tin cans or glass jars. An automated pumping system precisely fills each container with a preservative solution, which helps retain the pepper's fresh taste and extends shelf life without artificial preservatives. Once sealed, the cans or jars undergo sterilization in a high-pressure steam retort at 230 to 275 degrees for 15 to 30 minutes, depending on the packaging type. This process eliminates bacteria, prolonging the shelf life while preserving product quality. After sterilization, the canned peppers are cooled, then automatically stacked onto pallets, with protective padding between layers for stability. Once the required quantity is reached, the pallets are shrink-wrapped, or secured before storage or shipment. From a humble vegetable, bell peppers have become an essential ingredient in global cuisine, gracing everything from home-cooked meals to fine dining experiences. In French cuisine, they take center stage in ratatouille, a refined vegetable medley known for its harmonious flavors. Meanwhile, in the Mediterranean and Central Europe, stuffed peppers filled with a savory blend of ground meat, rice, and herbs offer a rich, comforting dish. On the grill, bell peppers add vibrant color and natural sweetness to skewers, pairing beautifully with meat, seafood, and cheese, creating a perfect balance of flavors and textures. Far more than just a vegetable, bell peppers embody the fusion of nature, science, and culinary artistry, enriching the world's gastronomy with their versatility and charm.